Hi, I'm James Williams and welcome back to my channel. So I've seen a few people recently talking about the RecordInfo PowerFx function, which is a really useful function that provides some information, as it says here, about a record of a data source. And that information is whether the current user has permission to either delete, edit or read that record in the data source. Which is great because you may want to change your user interface when you're building a Power App to make it obvious to the user that they're not able to, say, edit a record, rather than having them try and then an error comes up to say you don't have permission to edit this record at all, which is great. However, this function, at this time anyway, only supports Microsoft Dataverse, which is great if you're using Dataverse, but if you're like me and you use SharePoint lists as a data source for a Power App from time to time, then this isn't going to help you. So in this video, what I wanted to do was show you a way in Power Apps of doing the same thing. So examining the permissions the current user has to a particular record in a SharePoint list. So if that sounds interesting, please stick around and watch the video. So as luck would have it, there's a column against all SharePoint list items that's hidden by default, but that can help us in this situation, and it's called PermMask, which stands for permissions mask. So using the SharePoint REST API and this URL here, we have to specifically select this column, otherwise it's not shown to us, but we can get for a particular item. So here, the item with ID 1 in the list, test permissions, we're selecting the PermMask column so we can see what permissions the current logged in user has in respect of this particular item in the list. So we can see here that this is the set of permissions that I have to this particular item. It's a confusing set of numbers and letters, so that doesn't help us straight out of the box figure out what permissions the user has to the item. But we're going to look in this video at how to unpack this random looking string into something useful and meaningful. If you Google PermMask in SharePoint Online, you'll find this Stack Overflow article, which I found very helpful in working out what these strange strings mean. So you can see that the user was confused why in their SharePoint Online instance they were seeing PermMask values that didn't quite match up with what Microsoft was saying somewhere that these permission levels evaluated to in this PermMask column. So someone kindly has explained the whole thing in terms of how this magic column works. And basically what happens is for every permission in SharePoint, and here's the complete list, I'm sure, of all SharePoint permissions, view list items to enumerate permissions. Each one of these has a bit number associated with it. So the very first bit represents whether the user has permission to view a list item or not. So when that's arranged like this, you get a really long string of digits, zeros or ones, because this is binary. And binary digit 1 is actually at this far right side, the low order bit. So if that was a 1, then the user would have permission to view the item. If that was a 0, the user doesn't have permission to view a particular item. So these are actually all zeros and ones, which would go all the way up to, how many are there here? 63. So quite a lot of binary numbers there, zeros or ones. And then what happens is each set of 4 of those zeros or ones is encoded into a hexadecimal. So that's one of these after the 0x part at the start. You can get anything from 0 to F, where 0 represents 4 zeros and F represents 4 ones. So each of those 4 digits are encoded, and you get this shorter string with a 0x at the front, which we can ignore, but the digits after that are important. Each of these represent 4 binary digits. And from this big table here of which binary digit is associated with which permission, we'll be able to work out what the permission the current user has. So to test this and see what it looks like in action, I've prepared a test list in SharePoint Online, and I've created 6 items in this list, which I've named in the title column full control, design, edit, contribute, read, and restricted view, which were all the options available to me in terms of permission levels to pick. So I've assigned the test user which is not me. I'm a site collection administrator here, so none of these permissions will actually make a difference to me. But for the test user, they have permissions to each item. So the contribute item, say, if I click on manage permissions for that item, these are all uniquely permissioned. So for the contribute item, test user has contribute access, and for full control, say, the test user has full control access. So the same for all these 6 items. The test user has only the permission that matches the title. So how does that work in SharePoint Online then? So all those things I'm selecting there are permission levels. So if I go right to the top level of the site and I look at the advanced permissions page, this is what I get. If I go into permission levels here, you'll be able to see there are those. Well, there's the 5 default ones. Restricted view is a special one that was available to select, but it's not listed in this list here. But for all these items, which we can't edit because these are the out of the box permission levels, but we can add our own custom permission level should we choose. For each of these permission levels, there's a whole set of permissions. So if I go into full control, you can see all the boxes are ticked, because full control has all the possible permissions on SharePoint Online to a particular, well, in the case of a list item. So that's all these tick boxes here correspond to those many different permissions that we saw here. So each permission level is a collection of permissions. So the full control permission level is the amalgamation of all these permissions. So if I go into a much lower permission level, read, in which case a user can't edit any items in SharePoint lists, you can see that most of these boxes are now unticked. And that shows that a user can't edit an item, they can't manage the list, but they can view items and they can open them. And there's other things here, like they can view application pages, which allows them to get to the view of the list in SharePoint to actually see the items. And all the way down, most things are unticked there. So this is what we're going to test for. And the reason we can't just test for what level out of these items a user has access to is, one, if someone's used a permission level, or if someone later creates a custom permission level and calls it anything they want, we've no way of knowing in advance what that's going to be called, so we can't check to see if a user has a particular level and know from that we know exactly what their permissions are. And secondly, you need permissions to be able to examine these permissions. So you can't see what permissions are assigned to a list item unless you've got the enumerate permissions permission. So the read-only user does not have access to do that. But that PermMask column is a special one in that it's different for every user that views an item in a list, and it does actually show them their own personal permissions to that particular list item. So that's what we're going to use today. So this is the flow that's going to do all the hard work for us. It's going to be triggered by when a PowerApps calls a flow v2 trigger. And in this trigger, the PowerApp's going to provide to this flow the following bits of information: site URL, the list name, they're both text type inputs, and finally a numerical input, the item ID. So in SharePoint that starts at 1 and goes up as long as you create items in the list. So there are the 3 bits of information that we need to send to that REST API endpoint to get the PermMask column back. So we need the site URL for the site address parameter here. It's always going to be a get method because we're just reading the value of that column. And then this is the URL of the API. So we go into web and lists. We get the list by the title, and that's coming from the trigger. We get the particular item we're interested in, again coming from the trigger, and then we're selecting the PermMask column. And then the last part of the flow is that it responds to the PowerApp with all the possible permissions. So for every single permission in that long list from that article there, I've added an output. So that's the final PowerApp. I've added an output. So these are all yes or no, so Boolean, true or false values. And for each one of these, I've put in a formula, a power automate expression, I should say, which will identify from the PermMask value coming out of this column whether or not this particular user has this permission. So I'll examine what these expressions look like in a moment. Then how does that look in the app? it looks like this. So for every item in the list, so I've got a gallery of list items coming from SharePoint here. I'm showing that title, so this is the permissions that the test user has to the item. And what's happening here is at the start of the when the app's launched and this screen becomes visible, we're gathering into a collection with clear collect every item from the test permissions list, and then we're adding a column to this collection. So we get all the items in, we add a new column and we're calling it permissions, and we're populating that value using the flow which I've called SharePoint permissions. So that appears here as SharePoint permissions.run, and then there's those three inputs, those three parameters for the flow that we're providing: the URL of the list, of the site rather, the name of the list, and the item.id, which is the ID of the current item. So that's gathering everything into this app. And then this gallery is displaying the items in that collection. And then there's a couple of things going on here. So on the right, I've just got a label where that whole response that comes back from the flow in that permissions column, I've just turned it into some JSON so we can see at once that all the various permissions coming back are shown. You can see here that they're all true or mostly true. The one that isn't true at the top is add and customize pages. So even me as a site collection administrator here doesn't have that permission, and that's because this is set at the site level for all users, whether or not you're allowed to add and customize pages. This is one of the things that prevents users from using custom script on a site. So there's all the individual permissions, but within that permissions column is a whole set of permissions set to true or false, just like we see here. So what I've done in this container is have 1, 2, 3, 4, 5, 6 more labels. So for the full control label, for example, I've given the name of the permission level, and I've also shown what permission I'm testing for to see if the user has that permission level. So these are the out-of-the-box permissions, and these are the permissions that would show that a user actually has this permission level. So only a full control user has the enumerate permission, whereas a design user wouldn't have that, but they would have approve items, which the edit user wouldn't have, and so on. So there was a useful Microsoft Learn article about this that goes through all the permission levels. So for example, in here, edit, you can see that the edit level has all the contribute level permissions plus manage lists. So manage lists had to be the one I chose for the permission to test for here. So if I look at each of these, if I go to the fill color, all I've done is set the fill color to green if the user has that permission. So I've done this item.permissions, that gets me the whole column of properties. And then I've tested for a particular permission here. You can see, you can, if you want to, drill into this property and see all the possible options that we can check for. So these will return a true or false. So if it's true, we'll get green, and if it's false and the user doesn't have those permissions, we'll see red. But obviously in this app, I'm viewing it as the site collection administrator. So even though I don't technically have any permissions to these list items, only the test user does, because I'm the site collection administrator, I've got all the rights to every item anyway. So here's the app being viewed by the test user, who has run as rights to the flow. So the flow is being called for each of these list items when the screen becomes visible. And we can see that for the full control item, all these boxes are green, but as we go down the list, they fall away and become red. So by the time we get to restricted view at the bottom, only that item is green, and all the other permission levels are red to say that the user doesn't have that permission to those list items. And you can see here in the full list of permissions, we're starting to see a lot of falses, whereas at the top, the user had all trues except, again, for that add and customize pages permission, which is set at the site level. So back in this final respond to a Power App step in the flow, these are the expressions. Now, it wasn't particularly easy to enter these, so it was quite difficult for the flow maker here, but the result of doing it this way is that, one, we're using as few actions in the flow as possible, because this flow could be called a lot of times if you're reading a large SharePoint list into a Power App. So we're trying to minimize the number of calls to the Power Platform here by having literally only the actions we need: a trigger, a response, and that one step in the middle to ask SharePoint what the PermMask column value is. So each of these expressions is exactly the same, except for in the second and final line there, this one starts with the number 1, because that was the bit number associated with view list items back in that diagram, all the way down to enumerate permissions, which was 63. So if I go down to the bottom here and see enumerate permissions, hover over that, I can see that it's 63 at the start of the final line there and the second line. And I mainly laid out the expression in that way so that it would make it easy for me to copy them down and then edit those bit numbers. But that was quite tedious. But let's look at that expression now and see what it's doing. So here we are in VS Code, where it's a bit easier to see what's going on in this long expression, particularly because of the language formatting with all the colors. We can tell which bracket belongs to which closing bracket, which is very useful when editing a long expression to make sure that you get the right number of brackets. This is the version I copied into the output in the flow, mainly because the bit number to replace is at the very start of each of the second and third lines there, which made it a lot easier to paste this expression in and then change just that bit number in both locations. But apart from the fact that it's crammed down into 3 lines, it's exactly the same as this larger expression up here. So we'll walk through this now to see what it does. So first of all, it checks if the bit number that we're looking for is greater than the length of the binary string. So this is an expression that generates the length of the binary string, the number of zeros and ones that we get. Because I found if the binary number didn't have, say, that enumerate permissions permission level represented, which is the 63rd bit, it might only have so many hexadecimal characters, and that when expanded out into binary, that wouldn't be all 64 bits. So if we try and extract a bit, say the 63rd bit from the binary string, and the length of that binary string is lower than 63, the flow will fail. So the first thing we do is check that we've got enough bits in the binary number compared to the bit we're looking for. And if the binary number is shorter, if the bit number we're looking for is longer, is higher than the length of the binary number we're looking at, then we'll just provide false, because we know we're not going to have the true value, the one binary number in that position, because we don't have that position at all. So we'll just return false. And in that way we stop the flow from failing. But if we do have a binary number long enough to check what this bit is, then that's what we're going to do here. So we're going to return a Boolean value, which is a true or false, to show whether or not the particular permission bit that we're looking at is there. So looking at the way this works, we'll go to the middle part of it first and work our way out. So this is the part of the PermMask column that comes back from the SharePoint API request. And the first thing we're doing is getting the substring of that column, because it always starts with 0 and X, which just shows us that it's a hexadecimal number. It doesn't actually tell us anything about the permissions, so all we're doing is trimming those first 2 digits off there. And we did the same above to calculate the length of the string by getting the relevant hexadecimal characters, getting how many of those we had with length, and then multiplying that by 4 in order to get the binary number's length, because each one of those hexadecimal characters is converted into 4 binary digits, as we said before. So again, here we're taking the substring, we're getting only the useful hexadecimals, and then we're going to convert those into binary. And to do that, we're going to replace each of the hexadecimals, so from 0 to F, with the relevant binary digits. So F is 4 ones, all the way down to 0 being 4 zeros. The thing you've got to be careful of here is that you don't replace, say, one of these digits first, put in a load of zeros and ones, and then later come to replace the 0 and 1 with the binary, so the 0 and 1 hexadecimals with the binary equivalent, because then you'll be replacing all these that you've already done. So what you could do is replace the zeros first with 4 zeros, and then replace all the ones with 0, 0, 0, 1, and then you'll have no more hexadecimal zeros and ones in there. But just to be doubly sure, and to kind of emphasize the point here, I've just got rid of the zeros and ones straight away and replaced them with another character, so a little o and a little l, because they look like zeros and ones, which I've then replaced with their binary equivalents later on. But you don't have to do it this way. I was just trying to make it clear that we don't want to be replacing them in things in the wrong order and replacing binary characters that we've already converted with more binary later down the line. So be very careful about how you replace all the hexadecimals with binary. But once that's done, you get a binary number which is up to 64 digits long, all zeros and ones. And then what we're going to do is compare a particular digit, which we're going to extract using the substring function, a substring of length 1. We're going to see if that substring equals a particular value. So we'll use the bit number to take one digit out, and we're going to see if it equals 1. And if it equals 1, then the bool function here returns a true, and if it equals 0, or say that it will be a 0, but it won't equal 1 when we compare it, then that will return a false here. And actually, looking at this now, I don't need this bool at all, because equals will give me back a bool. So I might tidy that up later on. But the important bit then is how we select what digit to extract out of that binary number. So that's done by this part of the expression here. So the first thing that this bit's doing, again, is getting the length of the binary number. So this could be anything up to 64. And then we're taking away the bit number we're looking for from this number. And the reason we're doing this is, if you remember, say for the view list items, which was bit number 1, bit number 1 is the low order bit, the lowest order of all bits, which is right at the right hand side, the far end of the binary number. It's not the first one, which will be the highest order bit. So in our permissions mask, 63 is the highest one. So that will be, of all the permission bits, the leftmost of all of them. Whereas bit number 1 is this one over here. So in our expression, we're not looking for a substring for character 1. We want the very last digit. So we take the length, which is anything up to 64, and we take, say, that 1 from it. That will give us 63 in that example, which in the case of substring will give us the last in a string of 64 characters, because it's 0 based. So it starts at 0, goes all the way up to 63. So which is why we just take the total length, we take the bit away, and we get therefore the index of the substring, the index of the binary digit that we need to use to get substring to provide us with the actual value. So for view list items, a bit is a 1. The length of the binary number is 64. So this sub expression gives us 63. And then we tell it that we want a substring of length 1. And that, make that a bit clearer by putting that there. That will extract 1 digit from that string. And if that equals 1, then that gives us a true back in the output to the Power App. So here's that expression tidied up slightly. I've got rid of that bool that wasn't necessary, and I've moved the brackets around a bit so they're a bit neater. So for those of you that have stuck around this long, this is the final expression. If I scroll along here, I've still got that O and L in there. Potentially you can get rid of that as well. But that's the expression. And if we go and take a look at the result, this is what happened in the app. So we could see that we've identified what permission this particular user has to all these list items. This is the actual permission. So if they're a site collection administrator, these will always be green no matter what the permission level is. So we get the actual permissions the user has, whether or not that's been assigned to that particular list item. So that's the finished function and the finished app. I hope you enjoyed this video. If you did, please drop a like and consider subscribing to the channel. So all that leaves for me to say is thank you so much for watching. I hope you enjoyed it, and I'll see you later, Automator.